Defined scope. The project scope is established through the defined scope process. In most cases, the product scope will also be created through activities in this process or undergo revisions. The project scope statement explicitly describes all the project deliverables and the work necessary in order for the project to meet its objectives and all its approved requirements. The scope statement needs to contain or reference other documents that describe all these elements. Product scope. The characteristics of the product, service, or result for which the project was undertaken. In projects that are part of a larger program, the project itself may only be creating components of the product, but the product scope or product description is still necessary so that everyone knows what the overall objective is. Project objectives. Objectives are the success metric for the project. Specifically, what will it take for the project to be considered successful? This includes the business, cost, schedule, technical, and quality objectives, and other specific targets should be included where applicable. Project requirements. The capabilities that the product, service, or result must possess and meet. Requirements are the translated expectations and needs of the stakeholders into prioritized, descriptive requirements and work items. Project exclusions. Nearly just as important as what is in the project, the scope should include items that are excluded from the project. Doing this helps eliminate any confusion within the stakeholders or project team. Project deliverables. The core product, service, or result should be fully described, as well as any ancillary deliverables. Any needed project artifacts, those documents not directly related to the deliverables, such as management, technical, or status reports, should also be described. Product acceptance criteria. The process and criteria for product acceptance should be defined. This includes customer-specific requirements and any testing or other threshold limits. Project constraints. Any limiting factors the project must work within, such as deadlines, budget, staffing, facilities, equipment, materials, or contractual restraints, should be described. Project assumptions. Every project has assumptions, and these should be described because assumptions are risk factors. Risks. Risks should be identified at least at a high level. The risk register is where all risks are logged, but having major risks explained in the scope statement helps make everyone aware and on the lookout for them. Milestones. Any important dates, including deliverable or artifact-oriented dates, should be included in the project scope statement. Approval requirements. Any specific approval requirements for items such as deliverables, documents, and work should be described. Defined scope. Inputs. Project charter. The project charter formally authorizes the project and the project manager. It also provides the business case, objectives, and success criteria of the project. The charter provides the framework for the project requirements. Requirements documentation. The product scope and project objectives are broken down into requirements and described in a collection of requirements documentation that's applicable to the project and requirement type. Requirements can be documented and described in a number of different levels: executive, summary, and detailed, and in a variety of methods textually or visually. Organizational process assets. Organizational process assets are the source of existing policies, processes, organizational data and knowledge. These assets include the entire collection of formal and informal methodologies, policies, procedures, plans, and guidelines, as well as the organization's knowledge base, which includes historical performance data, labor information, service and maintenance history, issue and defect history, project files, and financial data. In developing requirements and the project scope, templates, checklists, and lessons learned from previous projects are useful. Define scope. Tools and techniques. Expert judgment. Expert judgment is based upon the experience and knowledge of subject matter experts. It's used to assess and evaluate the inputs and the information they contain. Product analysis. Product analysis translates product objectives into tangible project requirements and deliverables by dissecting the product into components. Alternatives identification. Finding alternatives looks for different approaches in performing the work required by the project or in the methods for achieving the project's objectives. Alternatives identification is applicable to many project components. Facilitated workshops. Facilitated workshops are interactive discussions with participants usually conducted informally to encourage an open dialogue. Facilitated workshops are central to many different methodologies, and include quality function deployment, voice of the customer, and joint application development. Define scope. Outputs. Project scope statement. The project scope statement details the measurable goals, objectives, deliverables, and requirements of the project, and what the acceptance criteria of deliverables will be. It also describes the work required to meet all objectives and deliverables of the project, and it also contains milestones, assumptions, risks, and costs. The deliverables will be compared to the project scope statement to make sure they comply with it. Project document updates. Defining the project scope is likely to uncover additional requirements, so updates to requirements documentation in the requirements traceability matrix are to be expected. Product analysis. The project scope can be developed without having a good understanding of the product, even if our project is only delivering a part of a larger product, service, or result. Disconnects between the product scope and project scope can result in deliverables that don't fulfill the need for which they were intended. Product analysis is a tool that translates product objectives into tangible project requirements and deliverables by dissecting the product into components. Some of the generalized methods of product analysis include use cases modeling. These are step-by-step accounts of system behavior and how it interacts with a user. These are very common in software development projects, but they are also widely used in other industries. User scenarios, user stories. These are also step-by-step accounts, but they take a more fictional narrative approach, and they are usually written by the customer, user, or analyst, and they describe interactions less from a system standpoint as they do from what the customer needs the product to do. Product breakdown. This approach takes a complex product and separates it into simpler components that can be more easily described. Functional analysis. Functional requirements. These approaches take an even more detailed approach than use cases, and describe in detail specific functions of the product from the system's viewpoint. Systems engineering. This approach is highly different from industry to industry, but it generally takes a broad, overall view of the product lifecycle, focusing on balancing the customer's needs, cost, quality, and complexity. Quality function. A quality management practice whose goal is to fully understand the customer needs. Alternatives identification. There is usually more than one way to solve a problem or reach our project's objectives. Alternatives identification looks for different approaches in performing the work required by the project or in the methods for achieving the project's objectives. This can result in project and organizational benefits, such as less production costs or time, better quality, or competitive advantages. Alternatives identification can also turn up methods of addressing stakeholder concerns, usually negative, while still maintaining the integrity of the project's objective. Looking for alternative solutions requires energy, effort, and creating an environment where this behavior is encouraged. Project managers may need to lead and encourage stakeholders and the project team through creative thinking techniques. We're speaking here about technical creativity, new techniques, technologies, processes, and procedures rather than artistic creativity, though that form of creativity can also be applicable to some projects. There are two main branches of technical creativity: program thinking and lateral thinking. Program thinking is based on pattern recognition, and humans are especially good at this. We're able to recognize images, pictures, objects, situations, and learn by cause and effect. This type of thinking can help us refine and improve our work processes, but it generally leads only to small, incremental improvements. And the very fact that we rely on past experiences in program thinking can get us into a rut by approaching problems the same old way. Lateral thinking does not completely disregard program thinking, but it uses tools that help us break up the patterns and see things differently. Techniques such as brainstorming, free association, and mind mapping are lateral thinking techniques. The results of these techniques are a large pool of ideas which can later be reviewed more thoroughly. Regardless of the lateral thinking technique used, there are general guidelines that we can use to encourage the process. Creative thinking is not an inherent talent. It can be learned and improved upon by anyone. Creative thinking requires us to believe we are creative self-perception, so encourage, reinforce, and reward creative thinking of the project team. Creative thinking is usually enhanced through a group setting rather than an individual activity. Do not criticize or judge any initial ideas. All ideas, even the most silly and absurd, should be welcomed. In the initial stages, quantity is more important than quality. Scope baseline. Once the scope is approved and the WBS and WBS dictionary have been created in Section 5.3, the scope baseline comes into existence. Scope baseline is the collection of the approved project scope statement, the work breakdown structure, and the WBS dictionary. All project baselines are the current plans that have all approved changes incorporated into them. Once these documents are approved in some manner, the baseline is created, which just means that any further changes must go through the change control process. Baselines are not the original plans. Though this may seem illogical at first, an example may help us better understand baselines. Imagine that we originally planned for a low-budget surprise birthday party for a friend and had invited 5 other people. It was going to be held in our home and everyone was going to chip in and bring food. The entire event was only going to take 2 days to plan and cost no more than $100. But later everyone agrees that the guest of honor deserves a bigger party, and so it's now going to be held at a restaurant with dinner and drinks for 50 guests. The party is going to take us 7 days to organize and will cost $5,000. The big day arrives and everything comes off exactly as planned. Was our project successful? If we look at the original plan compared to what actually occurred, it took us 350% longer to execute the project and we exceeded our original budget by 50 times. However, the original plan is not what our comparison should be based on because the scope of the project changed midway through. Our comparison should be based on the 7-day schedule and budget of $5,000. The purpose of any project management baseline is to provide measurements off the approved plans. We want what's currently been agreed upon as our measuring stick, and when we do this with the example, since the original plan was altered and agreed upon by all the stakeholders and we performed exactly as we expected, the project should be considered a success.